Welcome back. We're going to be looking at section 2-5 using linear models. We're going to come back to using scatter plots, which I'm sure you've used before in the past, talking about lines of best fit, talking about an R value. Some of those things might be a little foggy, but hopefully after today, you'll be a little bit stronger with them. So first of all, we need to talk about correlations. What a correlation is how we can compare two pieces of information, and whether there's a strong relationship, whether it's a weak relationship, maybe there's no relationship between it. And there's 5 different models we can kind of look at. The first one is if we look at this one right here. All these different plots, all this data that we gathered, if we were to plot it, kind of looks like this. As you can see, the dots start up here, and kind of you can see a trend that as you move farther to the right, they go lower. And if you see, a lot of the dots, if I put a circle around them, it's kind of like a narrow line, or a narrow circle, narrow ellipse. If this happens because it's going down, left to right, this would be a strong negative correlation. So it's strong because all the points are kind of close together. The next example we have is we can kind of see the dots are going in, kind of going down still, but they're not as close together if we were to fit them on a line. So if we put a circle around them to enclose everything, you can kind of see that this is a lot more round than this. There's still a little bit of a relationship here, but it's not strong. We would call this a weak negative correlation. So there's a little bit of a relationship, but it's not very strong. The third model is kind of like you're taking a shotgun and you shoot and just sprays everywhere. There's no correlation between whether the points are here or right. And if we kind of enclose them all, it almost looks like a zero or a big donut. This means there is no correlation. There's no relation between the two pieces, the two variables we're talking about. Something like this might be comparing someone's height with their intelligence. That has nothing to do with it. You could be 6'4" and a genius, or you could be 6'4" and not the sharpest tool in the shed. It doesn't matter. The height compared to intelligence. Now if we turn it around, the dots are kind of going up. And if I enclose these, it makes kind of a wider circle, kind of like this, but just in a positive light. It's increasing this way. So this would be a positive, or a weak positive correlation. And the next one, you can see all the dots are kind of close together. And if we enclose them all, again, that's a lot thinner circle, a lot thinner enclosure. The thinner it is, the stronger it is. So this would be a strong positive correlation. Now hopefully you notice that the correlations, whether they're positive or negative, kind of go with the slopes of a line. That kind of helps. That's why we're talking about linear models. We're thinking about a line kind of going through the middle of them. The closer the points are to that line, the stronger the correlation. Now one way we can identify this is using the R value. Okay? The R value. The R value is how we can kind of compare these different things. So, looking at this, we know that the R value, well, we don't know this, you will know this, is going to be between -1, this would be a strong negative correlation, all the way to +1. That'd be a strong positive correlation. So the numbers are going to lie between -1 and +1. Nothing bigger, nothing smaller. So if I had to guess on this, my R value in this model, and you can write this down, R would equal a negative maybe 0.8. It's close to -1. Whereas this, because it's weak, it's a lot, the points are farther apart. Again, if we kind of drew a line through the middle, you could see that the points are really close here. If we drew a line through the middle of this, the points are farther apart. This is a weak negative correlation. The R value here might be -0.2. So you can put that down in your second example from your notes. There's no correlation. The R value is 0. Now, if it's positive, it just goes in reverse. This is a positive 0.2 for our R value in this one down here. Again, I can see that if we draw a line through it, it's going to make it where the points are a little bit farther apart. Whereas here, if I drew a line through it, the line isn't too far from where I enclosed all my points. This is a strong positive correlation. It's a lot closer to a +1. So maybe I say it's a positive 0.8. Again, it's close to 1. Something that is a true +1 would be where every point lies exactly on the line. A negative would be where all the points are lying on this line, and there's no deviation from it. This would be a -1 if they all lined up on the line. A +1 was if they lined up on that line. And then the other extreme is if it's kind of like a shotgun, where it just gets spread out. So the R values kind of correspond with how close the points are to making a line. So filling in with the notes that I provided you, it says the R value, the closer the points are to making a line, and this is where I want you to fill this in. Okay. So the R value. The closer the points are to making a line, closer the points are to a line, the closer the R value is to -1 or +1. So I'll let you write that down. I see there's a little sheen there. So I kind of move it a little bit. Hopefully I can avoid that. It's not really working. So the closer the points are to a line, the closer the R value is to a -1 or a +1. Now, the farther the points are to a line, so you want to fill in that part. The closer to 0. Closer the R value is to 0. So you want to make sure you have that down and copy that down. So we will look at this a little bit more in depth in the next video. But remember, if the points can fit really close to a line and they're going up, it means a strong correlation, strong positive correlation. If they're going down, it's a strong negative correlation. If they're a little bit farther apart, where that kind of, if you encircle around the points a little bit wider, it's a weaker correlation. And if it just makes like a complete circle, it'd be a zero correlation. So we'll pick up this on the next video.